All right, so let's take a look then at what we've got for this week. We looked over the answers there. Let's take a look at what we've got for this week. Obviously no class there. Today we're basically we just did the bond energy review. We want to check formal charge. And then we have bonding review for Friday's test tomorrow. Start organic notes on Thursday, test Friday. Sound good? Cool. Let's go ahead and take a look at formal charge. A formal charge is one of those things, for some reason, seems more difficult for students. So hopefully that won't be the case for you. So in order to calculate formal charge, we take the number of valence electrons for a particular atom. How many valence electrons does a nitrogen atom have?
5.
5. And we subtract the number of bonds and the number of lone pair electrons. Or if you want, you could say dots. So how many bonds does this nitrogen have?
4 total bonds.
4 total bonds. We're not saying bonded atoms this time. Yep. So we're actually counting the bonds, not the bonded atoms, because we're counting 1 electron, 2 electron, 3 electron, 4 electrons. So 5 minus 4 is 1. So the formal charge of that nitrogen is 1. What's the formal charge of this nitrogen? Well, again,
Minus 1.
5 for the valence electrons, minus 2 for the bonds, 1, 2, 3, 4, minus 4 for the dots. So 5 minus 2 minus 4, that would be -1 for that guy. How about for this carbon? What would the formal charge be?
0.
0. Good, good. How about for each of those H's?
0.
Why?
Well, since they have like 1 valence electron and you have 1 bond, 1 minus 1 is 0.
There we go. So each of these have 0 over here. And you have to do this for every single one. So if we take a look here, somebody want to do the oxygen here?
Is it 0?
It is 0. We take a look, we have 6 for the valence electrons, minus 1, minus 2, right? So that brings us down to 4, and then subtract the 4 dots. How about this nitrogen here?
Zero.
So we have 5 minus 1, 2, 3, 4, 5. How about this oxygen? Somebody else?
0.
Somebody from the class said 0. Amari said 0. 6. 1, 2, 3, 4, 5, 6. I'm going to rewrite this real quick so that you can understand what we're actually doing here for the formal charge. So if we look at this bond between the nitrogen and oxygen, it actually looks like this, right? So what we are doing is we are finding the electrons. I should probably not put dots around it, but we are finding the electrons closest to that, and we are comparing it to its number of valence electrons. Remember, we've said this when we talked about like carbon, and actually it's in this one right here, this example. What is carbons here?
Zero.
Try again.
-1.
-1. -1.
-1. So that means that this carbon has an electron that wasn't part of its valence electrons, because normally carbon has 4, but right now it currently has -1, right? And we said that that's that coordinate covalent bond, if you remember that term. What does the oxygen have?
+1.
+1. It has +1. So if we take a look, that right there is going to basically tell us that the oxygen kind of has lost an electron, or it doesn't. It has one less electron than it normally would have, right? So that's what formal charge allows us to see. Now the cool thing is the formal charge of this atom and this atom has to equal 0. All of the formal charges of all of these atoms have to equal 0. Here we had a +1, here we had a -1. So again, that has to equal 0. Well, where am I going for this? Well, if you have something, for example, SO4, when you add its formal charge up, it should equal -2. So let's try that. Who's the internet guy in here? Who's the one that looked at the internet last week? Nicholas, right? Is that your group? Yeah. So if you had it like this on anything before today, you would be considered correct. What is the formal charge of sulfur?
Oh, +2.
+2, right? That's not very close to 0, is it? In reality, the formal charge of sulfur is +2, and all of these other things have a -1. That is not a good formal charge to have. You want everything to be as close to 0 as it possibly can be. How can we go from +2 to 0? Come on, Nicholas, what did the internet tell you?
Make a double bond.
Make double bonds. If you look up on the internet what the Lewis structure for sulfate is, it will give you this. If you find the formal charges, you want them, if you can draw the structure so that it is as close to 0 as possible, it's a better a better structure. Let's find the formal charge of S now.
0.
0. What is the formal charge of this oxygen?
0.
0. That one is identical, so it is 0. What is the formal charge of this oxygen?
-1.
And this one also is identical, so that's -1. That gives us that -2, and we have most of the things at 0. So this is the actual Lewis structure for sulfate.
So would you count us off if we wrote the Lewis structure as the other one, or?
At this point, since I'm teaching you this, the other one would not be correct. I won't
Okay.
count off on anything in the past, though.
Okay, thank
Yep.
you.
So who's in the center for this guy?
Chlorine.
Yep. So our old way of doing this would be to do this. But science says that that's probably not the true or best structure because the chlorine here has a formal charge of what?
+3.
+3. So can anybody tell me a way we can get the formal charge of chlorine down to 0?
Make 3 double bonds.
You got it. And that is going to actually make 3 of those oxygens at 0 as well, with leaving only 1 oxygen at what?
-1.
Yes. But keep in mind that, so this would be 0, 0, minus up, 0, and -1. Keep in mind that these would be showing resonance, but I'm not going to have you draw the resonance structures for all of these because that's not what we're testing on for this right here. We're wanting to make sure we understand formal charge.
How do you know that it's the formal charge of that is +3?
What's the number of valence electrons that chlorine has?
7.
What is 7 minus 4?
3.
There we go, right? And you might be caught up. Some people get caught up because I am drawing lines here instead of dashes. So it does, you've got to, it's all up to you how you want to do it. But you got to realize that when you're doing the formal charge, if this is 2 dots, and then this only counts as 1 whenever you're subtracting it, right? So there is a lot going on here. These, again, only count as 1 when you're doing the subtraction. Shall we do one more? Let's do this one. P, O, 1, 2, 3. Normal world would say we would have this. What's the problem? P has what?
The formal charge of +1.
Formal charge of +1. Is there any way we can make it 0?
Add a double bond.
Double bond, how, what about the to the Cl or to the O?
To the O.
Why? Why can't we do it to the Cl?
Wouldn't that make like the formal charge not 0?
Yeah, right? If we added it to the Cl, we would have 7. We would have 7 minus 1, 2, 3, 4, 5. Right? If we make it with the O, now we have a formal charge of 0 for this and 0 for this. So we have 2, 4, 6, 7. So 0, 0, 0. Easy enough. Questions, questions, questions? No? All right, then. I would like for you to take the rest of the time today to go through and assign formal charges to these guys. And then to figure out, now this is the advanced lesson here, to figure out how these should be drawn. If you don't want the advanced lesson, that's okay, because you can use the alternative instructions here. Draw the Lewis structures that obey the octet rule like you're used to, and assign the formal charge for each atom and each molecule. If you do that, you should be able to see that they don't have the lowest. But if you can, figure out how you should draw them so that the formal charges are better. That's what we want. That's the advanced lesson. But if you can't do that, if you're like, whatever, that's crazy, at least be able to draw these and assign the formal charges to each of the atoms. If you can figure out how to draw them, I don't care if you tell me the formal charge or not. If you can figure out the correct way that they should be drawn without looking at the internet. Are we
So
good?
on a test,
Do you want to
you
see?
asked us
Go ahead.
on a test, if you asked us like what's the correct Lewis structure, you won't try to trick us and put like two different ones that one kind of minimizes the formal charge, but both are correct.
No, and to tell you the truth, most of the testing on this, everything even up to the AP exam says, what is the formal charge of this particular atom? And they give you the Lewis structure.
Oh, okay. Thank you.
Yep. And I can't say for that one you're taking. I don't know about that one. I've never seen it.
Yeah, they usually just give the Lewis structure and they say what the formal charge is.
Okay. Yep. This, this is advanced, but with us going digital and stuff like that, and you guys using the internet, I don't want to sit there and try to lie to you. Like whenever somebody says, "Hey, you said it's like this," and then it's like this, I want to show you why the internet says it's like that, right? Because we do have a lot more people going to the internet for sure for help. So that's all I got. If you have questions, by all means, stick around. Otherwise, get out of here. Have a great day. Get that done. Take care of yourself. Bye. Noah, did you figure that out? How to submit it? Just take pictures of it, my friend, and just submit them.
Yes. Yeah. I'll do that tonight.
All right, cool. No rush. I'm not gonna grade those by the end of the day, I don't think. Yeah, sorry guys. If you guys have questions, you're more than welcome to stick around. I am gonna pause the recording. That way I can get this, and I'll probably end up exiting the chat unless you guys have questions.